Hi, welcome to Physics 3.3c on net force. First, let's go over some things to establish. Net force is, remember, the total of all the forces in vertical and horizontal directions. If the net force is zero, the object is either standing still or moving at a constant speed. If the net force is not zero, the object will accelerate. And forces in the same direction will add, while forces in opposite directions will subtract. But remember, again, we're looking at vertical and horizontal, not anything at angles. So part one, we've got to be able to connect force diagrams and calculating force. So here's a cat sitting on a mat. We're going to draw a force diagram. If the cat has a mass of 17 kilograms, what's the force of gravity? What's the force of normal? And then what's the net force? Well, the force diagram would be the force of gravity going down on the cat by the earth, the force of normal going up on the cat by the mat. Then, calculating the force of gravity is mass times acceleration, which would be 17 times 9.8 here on Earth, which would be a force of gravity of 166.6 newtons. Since the cat is not moving, the force of normal on the cat by the mat is 166.6 newtons, and therefore the net force is zero. Part two, what happens if you have more than one object? Well, if you have a swing, if the swing has a mass of 20 kilograms and Joe is sitting on the swing holding his dog, what is the force of gravity and what is the force of tension in each rope? So the force diagram, right, for this would be force of gravity on the swing by the earth and the force of tension on the swing by rope 1 and by rope 2. And no matter what we put on the swing, the force diagram doesn't change. If the swing had a mass of 20 and Joe had a mass of 48 and the dog has a mass of 12, then the force of gravity would be the total mass of 80 times 9.8, which would be a downward force of gravity of 784 newtons. If it's held by two ropes, then we take the force of gravity divided by the number of holds to get 392 newtons in each rope. Part three, how do you find the net force? Well, this is what the simulation you played with was all about. To find the net force, we simply add or subtract the given forces. To find the net force, you again add or subtract the given forces. So this net force would be zero. What happens to an object if the net force is not zero? Well, to find the net force, we add and subtract those given forces. If the net force is not zero, we have acceleration. And with acceleration, we can find velocity, distance, time. Yay, kinematics! So here's a situation. What is the acceleration? If the force is applied for 12 seconds from rest, how far will it travel and what will be its final velocity? So acceleration should be force divided by mass, and notice that the net force was 225 newtons, right? Because 450 applied, 225 of friction makes 225 net force of a mass of 90 kilograms. So the acceleration would be 2.5 meters per second per second. Then, for 12 seconds, how far will it travel? Should be 180 meters. Welcome back to Kinematic 2. Finally, then, looking at the velocity, Kinematic 1, 2.5, the acceleration times the amount of time would give us 30 meters per second. Hope this helps. Thanks for watching.